So today we're going to be doing problem 1.7 from Fundamentals of Heat and Mass Transfer. And the problem is, the inner and outer surface temperatures of a glass window 5 millimeter thick are 15 and 5 degrees Celsius. What is the heat loss through a 1 meter by 3 meter window? The thermal conductivity of glass is 1.4 watts per meter K. So let's start with our knowns. And what do we know? We know that thickness, we'll call it T, equals 5 millimeters, and I'm going to convert that to 5 times 10 to the minus 3 meters. We know that the T inner is 15 degrees Celsius, and the T outer is 5 degrees Celsius. And we're just going to say, we'll call it W for width is 1 meter, and the length is 3 meters. For the window. We also know that the K of glass is 1.4 watts per meter Kelvin. So then, what are we trying to find? We are trying to find what is the heat loss. So we are trying to find heat loss, or more familiarly, Q is our heat loss. So then we can go ahead and make our schematic. And I'll go ahead and try my hand here at 3D. So we're going to have our window, make our little cube here. Great. And we have our 3 meter side, which I believe we called length. And that's L for 3 meters. We're going to have our 1 meter side, which we call W for width. And then we have our thickness here, which we call T. We know that this is glass, and so we have K there. And we'll call this side the inside, and this will be T inner, or I'm just going to shorten it to T in. And over here, we will have T outer, or I'll shorten it to T out. And that should be it. Now we can move on to our assumptions. And these should be getting pretty familiar. So for this one, it's going to be 1D conduction. And I'll specify in the x direction. And I will label the x direction as the thickness direction. So that's positive x. We are going to assume steady state conditions, per usual. Steady state, and constant properties, as we usually do. So let's go ahead and move on to our analysis. And for our analysis, we can go ahead and kind of skip right to our equation here. So we know that Q, or heat loss, equals, K, A, dt, dx. And we sort of know everything here already. So K we know is 1.4 watts per meter Kelvin. We know the area is going to be 1 meter times 3 meters. dt is going to be T outer. So I'll put this explicitly, is going to be T, you know what, the inside is hotter, isn't it? So T inner minus T outer, and that's going to be 15 degrees Celsius minus 5 degrees Celsius. And dx is the thickness, which I believe we said is 5 times 10 to the minus 3 meters. And if we look here, we want to make sure our units check out. Our meters on the bottom are going to cancel with our meters on the top. And our Kelvin is going to cancel with our Celsiuses. And that's because the difference between Kelvin and Celsius is just addition or subtraction. And so we can treat those as the same, and we'll be left with watts, which is what we want. That is the unit of heat loss. And so if we put this into the calculator, that is going to turn out to be 8,400 watts, just about. And that will be our answer. And are there any comments we have about this problem? Not really. We could say there is a linear temperature gradient or temperature difference. I'm just going to say through the window. And that's all.